This video is just an overview of the basic principles of stoichiometry. Stoichiometry is when you're dealing with a chemical reaction and you know how much of one thing you have or how much of one thing you need, you can figure out how much of the other things. For instance, if you know the amount of one of the reactants that is available to you, you can calculate how much of the other reactant you need. On the other hand, if you know how much product you want to make, you can figure out the amounts of both reactants. The heart of stoichiometry is the mole-to-mole conversion. The conversion factor that you're going to use to accomplish this is a mole ratio. And the mole ratio uses coefficients from the balanced equation. Hence, the first thing you want to do when you get a stoichiometry problem is to write your balanced equation. Very often, however, you will be given grams and asked to find grams. This will add two more conversion factors besides the mole ratio. You'll start out with grams of one thing. You'll convert it to moles. You'll do the mole-to-mole conversion using the mole ratio, and you'll finally convert to grams of the other thing. So, the heart of stoichiometry is the mole ratio. Going from grams to moles will require to divide by a molar mass. In other words, multiply by the inverse of the molar mass. The final conversion, going from moles to grams, you just multiply by a molar mass. Here is an actual stoichiometry question that gives grams of one reactant and asks you to find grams of product that can be produced. The question is, how many grams of aluminum oxide solid can be made by reacting 100 grams of solid aluminum with iron 3 oxide? The other product will be liquid iron. The first thing we need to do is write a balanced equation. So, aluminum solid plus Fe2O3 solid makes Al2O3 solid plus Fe liquid. And we can see that the oxygen is balanced, but we have two aluminums in the product side. We need 2 on the reactant side, so we put a 2 on Al. We have 2 irons on the reactant side. We need 2 on the product side, so we put a 2 on Fe. This is the thermite reaction. At this point, we know what our mole-to-mole ratio will be. If we figure out the number of moles of aluminum that we have, we can multiply that by a conversion factor that has 2 moles of Al on the bottom. Al goes on the bottom so that we can cancel it. And the 2 comes from the 2 in the balanced chemical equation. On top, we have 1 mole of Al2O3, because the coefficient on Al2O3 is 1 in the balanced equation. This will give us moles of Al2O3. Since we're starting from grams of aluminum, we'll need the molar mass of aluminum for our first conversion. And if you look on the periodic table, you see it's 26.9815. That means that 1 mole of Al is equal to 26.9815 grams. By the same token, we're trying to find grams of aluminum oxide that can be produced, so we need its molar mass. And if you multiply 2 times 26.9815 for the 2 aluminums plus 3 times 15.999 for the 3 oxygens, you get 101.96 grams per mole, which means that 1 mole of Al2O3 equals 101.96 grams. Now we're ready to perform our calculation. We're going to start with our given quantity, which is 100 grams of aluminum, 100.0 grams of Al. Our first conversion factor should take it to moles. We're going to use this equivalence statement to do that. Since we're starting with grams, grams needs to go on the bottom. So grams of aluminum cancels. On top, we put 1 mole of Al, since molar masses are always for 1 mole. Our next conversion factor is going to be the mole ratio, which we get from the balanced equation as enumerated above. We have 2 moles of Al in the balanced equation. That cancels moles of aluminum. Up top goes 1 mole of Al2O3, since Al2O3 is the substance of interest. Our final conversion factor will take moles of Al2O3 to grams of Al2O3. There's the equivalence statement we're going to use. On the bottom goes 1 mole of Al2O3. Moles of Al2O3 cancels. Up top goes 101.96 grams. Now we've canceled units as we go and made sure that everything works. Time to punch it into the calculator. So on my calculator I type in 100 times 101.96 divided by, open parentheses, 26.9815 times 2, close parentheses, press enter, and at 4 sig figs I get 188.9 grams of Al2O3. Now you try a related problem. How many grams of iron 3 oxide are required to completely consume 100 grams of solid aluminum in the thermite reaction? Pause your video now and try the calculation on your own. Then you can restart the video and go through it and see how you did. The strategy is going to be to go from grams of aluminum to moles of aluminum to moles of Fe2O3 to grams of Fe2O3. So we're going to need the molar mass of Fe2O3, which is 159.7 grams per mole. And again, our balanced equation is 2Al plus Fe2O3 yields Al2O3 plus 2Fe. Now we're ready. 100.0 grams of aluminum. Convert to moles by dividing by the molar mass. 26.9815 grams of aluminum is 1 mole of aluminum. Verify that your units cancel properly. On to the next conversion. Now we're going from moles of aluminum to moles of iron oxide. So to get rid of moles of aluminum, we put aluminum in the denominator, and we have 2 moles of aluminum as our coefficient in the balanced equation. Moles of aluminum cancels, and there's 1 mole of Fe2O3 in our balanced equation. Finally, we need to use the molar mass of Fe2O3 to get to grams of Fe2O3. We'll put 1 mole of Fe2O3 on the bottom, because molar masses are always for 1 mole, never the coefficients in the equation. And 159.7 grams of Fe2O3 on top. Moles of Fe2O3 cancels, and we do our calculation. 100 times 159.7 divide by parentheses, 26.9815 times 2, close parentheses, press enter, 295.9 grams of Fe2O3. Remember, as you do your dimensional analysis, to write out all of your units and cancel them as you go. Thanks for watching.